Something out there is rewriting the rules. An object hundreds of millions of miles away is behaving like nothing our physics books ever prepared us for. And the deeper we look, the stranger it gets. If you're interested in mysteries the universe doesn't want to explain, make sure you stick through this one. Before we dive into the numbers nobody can make sense of, let's start with where this thing actually is. The object, an interstellar traveler slicing through our system, is currently drifting roughly 186 million miles from Earth, twice the Earth-Sun distance. Out there, sunlight is weak, temperatures are brutal, and comets normally quiet down and fade. But this one is waking up. The first shock came from a series of recent high-resolution images. An amateur astronomer, using a half-meter telescope, captured the clearest view so far. What appeared on that sensor didn't look like a comet gently shedding frozen material. It looked like a controlled phenomenon, almost engineered. A bright sphere of dust surrounding a nucleus and two razor-sharp tails shooting outward like beams of light. One of those tails stretches nearly 3 million miles into space, a clean line pointing directly away from the sun. That alone is impressive. But the second tail is the one that makes scientists stare in confusion. It points toward the sun and stretches over 600,000 miles. At that distance, sunlight and solar wind should be ripping material away from the comet, not allow it to stream inward like a river flowing uphill. And yet there it is, not just visible, but unnervingly stable. Multiple observers recorded the same features on different nights, under different conditions. No artifacts, no processing tricks, just a pair of impossibly thin, collimated structures maintaining their shape across millions of miles. Comet tails are supposed to spread out as particles disperse in the vacuum. These tails stay tight like cosmic laser beams. But here's where things get stranger. The outward-facing tail has the help of solar wind pushing along. The inward-facing tail, that one is fighting against the solar wind head-on. Every grain, every molecule is forcing itself in the exact opposite direction physics says it should go. For that to happen, the density of material in that sun-facing tail must be 1 million times greater than the surrounding solar wind. That is not normal comet behavior. That is something we don't have a natural category for. Even more bizarre, the ratio between the long tail and the short countertail, roughly 5:1, has stayed consistent for weeks, even as the comet rotates and travels through different parts of space. Natural jets flicker. They weaken, strengthen, or switch directions depending on what pockets of ice are exposed. But this object produces the same geometry again and again, as if some hidden mechanism is maintaining balance. By this point, astronomers expected the activity to settle down. They expected it to behave like every other frozen wanderer that has drifted through the solar system. But instead, a new mystery emerged, the kind that strikes at the heart of comet physics. To understand the next anomaly, we have to talk about sublimation, the process where ice turns straight into gas. This is what drives traditional comet activity. Sunlight hits the surface, warms it, and ice molecules escape into space. Simple enough, and the amount of material released depends directly on how much sunlight reaches the comet. At Earth's distance, sunlight delivers about 1,300 watts per square meter. At the comet's current distance, that drops to around 300 watts. Weak sunlight, weak heat, weak sublimation. So if you calculate how much ice should turn to gas at that distance, especially carbon dioxide ice, which sublimates at around minus 78 degrees Celsius, you end up with a mass loss rate far lower than what the images suggest. So scientists did the math, and the answer was jaw-dropping. To create the amount of dust and gas pouring off this object right now, it would need roughly 620 square miles of active ice sublimating at near-perfect efficiency. But we know the nucleus is only a few miles wide. Even at the generous end, its total surface area is about 30 to 40 square miles. So the numbers simply don't add up. You cannot get this much material from this little surface area, not with heat, not with sublimation, not with standard comet physics. The usual explanation will be fragmentation. If it broke apart into many pieces, the total surface area would increase dramatically, giving more room for sublimation. But high-resolution images from November 11th show a single intact nucleus. No shards, no cloud of debris, no cluster of fragments orbiting each other. Just one object, stable and solid. But here's where things begin to border on impossible. The comet should be dimming. After passing close to the sun, comets retreat into cold darkness. Their glow fades. Their tails shrink. It's predictable and well documented. Except this one didn't get the memo. Instead of quieting down, it continues to shine with almost defiant brightness. The coma, its surrounding cloud, remains dense and brilliantly lit. The tails hold their form. Nothing is weakening. A new analysis estimates the object is losing around 200 tons of material every second. Let that number settle in. 200 tons every second. Over just 2 months, that adds up to billions of tons. For an object with an estimated mass around 33 billion tons, it has already shed roughly 10% of its mass. Now here's the real problem. Losing 10% of your mass isn't subtle. A natural comet should be tearing itself apart. Jet patterns should change. The nucleus should shrink noticeably. Activity should spike and collapse as structural weaknesses open. But none of that is happening. The object remains stable, consistent, and disturbingly uniform. And if all that weren't enough, the thermal models nearly all fail to predict this behavior. Something is happening out there. Something powerful enough to produce enormous jets, maintain impossible tail geometry, and shed mass at a rate no natural model can comfortably explain. But we're not done yet, because if these numbers are correct, and if the structure is truly this stable despite enormous mass loss, then whatever is driving this activity is not behaving like a typical frozen body at all. There's an engine at work here, whether physical, chemical, or something entirely different, that we do not yet understand. So what do you think is happening to this object? Is this just an extreme outlier or a sign that our models are missing something fundamental? Share your theories in the comments. And if this kind of cosmic mystery pulls you in, don't forget to like the video. Here's my question for you. What would you consider the most plausible explanation? Unknown chemistry, unknown physics, or something even stranger? This is Nebula Signal.